Bismillahirrahmanirrahim. Myself Muhammad Zahid. I am the presenter of today's topic, that is MIMO antennas for future 5G communications. These are the authors list. I am a co-author of this paper and my affiliation is University of Engineering and Technology, Taxila. These are the contents which I will follow. First of all, I will discuss about the objectives of the paper that we have submitted. These are the objectives: to design the antenna for the 5G communication, future 5G communication, and to achieve the acceptable gain and the efficiency. Why we are designing this type of antennas for 5G communication? The major issue is we have to design such type of antennas that lies in all the range, like antennas, efficiency, and etc. To design MIMO network and to optimize the MIMO performance parameters. These are the achievements that we have achieved from the design. The first one is the proposed MIMO antenna system consists of 7 elements that I will show in the next slide. Its operating frequency band is 36.7 to 37.4. This antenna, single element antenna, is covering the 1 GHz bandwidth with respect to VSWR 2:1 at the resonant frequency of 37 GHz. What is why we are designing the antenna for 37 GHz? This frequency range allocated by FCC, Federal Communication Commission, for the 5G millimeter wave communication. The achieved realized gain is 7.7 dBi and its efficiency is greater than 96%. When we are designing the MIMO network, there is a major issue. There are many parameters like mutual coupling, isolation, and many others. The major effect is we have to take multiple antennas closer to each other, but we have to take care of isolation factor. That should be less than minus 15 dB from that. This reference came from different papers, but our antenna, our design lies in minus 20 dBi. This is the antenna that we have designed. The maximum size of our antenna is 14 times 16 millimeter square. We have used Rogers RD5880. It's dielectric material, and the ground is partial. This case shows a single element, and this one is MIMO network. That the substrate thickness is 0.508 millimeter, and the thickness of copper, that is a copper layer for the radiator for both ground and the patch, is 35 microns. The simulated 7 element MIMO system shown below. Like from the left side we can see the front view, and from the right figure, that is a back view. This is the S parameter of the single element, and its resonant frequency is 37 GHz that I have discussed in the achievements. This is a maximum, like minus 17 dB. It's a reflection coefficient at resonant frequency. This figure shows a 2D plot of the realized gain. The maximum gain is 7.712 dBi at the resonant frequency of 37 GHz, and from this figure we can also see the total efficiency is negative 0.2408 in dBs. When we will convert this dB into numerical values, we will get the efficiency of 96%, 0.96. Now I will discuss about the different parameters. That this is the isolation. What is isolation? We can see from this figure on the right side, like S11, S22, S33. These are the reflection coefficients that are above minus 20 dB. These are the reflection coefficients. But what is this? These are the S21, S32, many other parameters. For these parameters gone from 1 to 7 elements. These are the effect of one antenna to other antenna. These parameters, we can also say these parameters are the isolation. that I told in the achievements, isolation is better than, that means less than minus 20 dBi. From this figure you can also see. This one is envelope correlation coefficient. From most of the paper we saw that the envelope correlation coefficient should be less than minus 0.3 or 0.7, but in our design we have achieved the envelope correlation coefficient that is too much lesser, that is 0.01. This is effective diversity gain. At the resonant frequency of 37 GHz, our effective diversity gain for all the antennas, effect of one to others, there are almost 10 dBi. Next one is mean effective gain. Mean effective gain is minus 3.0 dBi for all the elements at the resonant frequency as well. Okay, these are the conclusion that we have proposed. Our antenna for 7 element MIMO antenna is proposed for future 5G communication. We attain the requirements of high isolation between MIMO networks, which becomes an ideal candidate for future 5G communication. The proposed antenna is designed which is compact in size, low in cost. Because low in cost, why low in cost? Because the Roger RT500 with a thickness of 0.508, which is easily available in the market. So this is a low in cost to operate for 737 GHz. In addition, the results show that the proposed antenna has good performance in terms of radiation characteristic, gain efficiency, and bandwidth. These the parameters we checked from the previous slides like results. These the results indicate its promising potential for the future application. What we will do in future, we will improve the gain and efficiency of this MIMO network, and we will also apply, there are multiple techniques like ABG, photonic band gap, electromagnetic band gap, etc., to improve this MIMO network and to improve the performance of this MIMO network. And we will also design the single elements like arrays and etc. to convert this 7 element MIMO network into massive MIMO systems, and to put this improved network for the submission of general publication. Thank you all. If you have any question, please ask.